I'm walking with my panther. I'm out in the woods. Ain't gotta worry none. My panther's always good. My walking with my panther. Being outside makes us smile. And we ain't gotta worry. Nobody come within a mile. All right. Hey everybody, hey, how's it? Mr. Pat here. It's another edition of Mr. Pat's Bag of Tricks. Again, brought to you from the Windward Boys and Girls Club in Kailua on the island of Oahu. Again, that was a harmonica introduction for a little bit of fun. And what I want you to think about today is a little bit of this music theory that goes with that. So instead of just playing, I'm going to talk to you a little bit. What happens in songs, what you just heard, I should say, is what we would call a traditional 1-4-5 slow tempo blues in the key of A. If you were here yesterday tuning in, then you heard a more up-tempo, a little faster speed blues in the key of G. But again, it was a 1-4-5. It went something like this. Now that's in G, different key. It's a different speed, but they share something in common. So in music theory, every key has like a scale that goes with it, notes that go with it. And they're written in a sequence and numbered. And they get a little complicated with flats and sharps and whatnot. But generally, they have a certain grouping that's similar to every single key. Just the notes themselves change depending on what key you're in. And certain groupings of those notes form together well to make types of songs. So 1-4-5, I'm going to show you what that means in writing here. Okay, here's the key of G and A. So just look at the top in G. So this is the key of G. See, I wrote root under the 1. So this, since G is what it's in, it's key, that's the root where everything begins, and that's the 1 chord. Then as you go up the line, there's 7 of them, G to A, B, C, D, E, and the last one, this is called F sharp, that pound thing. So 1 chord, 2, 3, C is the 4 chord, D is the 5 chord. So what we're saying is, in this blues progression, the 1, G, the 4, C, and the 5, D go together to make that a blues song. A very common practice in blues and rock and roll songs. In A, you can see for yourself, same exact thing going on. Remember, all those little pound sign things are sharps. So A is the 1, B is the 2, the 3 chord is the C sharp, the 4 is a D, the 5 is a E, and then so on. So again, that root is A, and the 4 and the 5 are D and E. So A, D, and E are the main chords to make that song. So when I was playing that, I'm playing the... Okay, we're ready. I'm going to play the A chord, the D chord, the E chord. And they go together and they make the song of blues. So when you go on stage and somebody says, hey, we're going to play a slow blues in G, then you know what they're talking about. You know they're going to have a G, a C, and a D in it. Okay? So that's just a quick little introduction. If that went over your head, that's fine. We'll do more of that later. What happens is you got to get this a little at a time, hear it more than once, and then it starts making sense. And then if you come join us when we're back in session, back in the music room, then we can put it to practice and show you what's going on. These 1, 4, 5 things also help you pick which harmonica to use, and that's another subject of another coming lesson. Okay, so music theory, 1, 4, 5 blues. Now we're going to switch gears. We're going to shift over to the whiteboard, and we're going to talk about a math lesson today. Okay, and we're going to be talking about things that you're fairly familiar with. No matter what grade level you're in, you've had to deal with this in math, about factors and multiples. We want to clarify what the difference is, have you do a couple of examples, nothing too heavy at all, and then apply it to a little bit of algebra, which you should have started doing as well with your factoring binomials if you're in 8th grade. So let me shift my camera around. Okay, thank you. All right, here we go. So we are going to start with a number to consider. So let's say 24 is what we're looking at. So consider the number 24. So factors and multiples are different. They might overlap, but they're basically different. To find the factors of 24, the factors of 24, what you want to do is think of any number that can divide into 24. What can 24 to be divided by? So it can be divided by, you think for a minute. Pick the number that's not too hard there. It can be divided by 2, right? 2 goes into 24, so 2, how many times does it go in? 12. So 2 times 12, in case you're in elementary school, I'll use the X. 2 times 12 equals 24, right? What's another number? 3. 3 goes in, if you know your times tables. 3 times 8 is 24. Okay, these things are factors of 24. 24 can be divided by 2, so 2 is a factor. 24 can be divided by 12, so 12 is a factor of 24. 24 can be divided by 3. 24 can be divided by 8, so those are all factors. Okay, if you keep going and thinking like that, you can get 4, and it goes in 6 times. So there's 2 more factors, 4 and 6. And a lot of people stop right there thinking they found all the factors, but there's 2 that are missing. So every number has 1 as a factor and itself. So don't forget when you're listing factors or searching for them that you can also use that. So 1, 2, 3, 4, 5, 6, 7, 8 different numbers divide into 24. So 24 has 8 factors. That's what we're talking about. These guys right here are the factors of 24. Okay. Now, not everything's a factor. So what about multiples? Can't really list all the multiples, but I want you to get a difference. A multiple is when you take 24 and you multiply it by something. Like it's actually its own multiple, but let's start with 2. So if I go 24 times 2, if we go 24 times 2, what's that going to be? 40 plus 8, 48. So 48 is a multiple of 24. If we go 24 times 3, 3 times 4 is 12. 3 times 20 is 60. 60 plus 12 is 72. So there's another multiple of 24. Okay, notice 24 are factors of this, but the key here is these numbers are multiples of the number 24. And there's no end to that. You could multiply it by 4, get 96, and 5, 120, and so on. But there's really no limit. But you need to understand the difference, because your textbooks, your teachers, your problems, some problems are going to want you to find multiples, like when you're adding, subtracting fractions and you need a least common multiple, that kind of thing. You put that to use. For factoring, you use it when you're reducing fractions. You use it in algebra a lot, when you're pulling numbers out to solve equations sometimes. But the factors are a very useful tool, and you need to be able to keep track of the two. Okay, so what I'm going to do is, I can't really ask you about any questions. Again, factors are numbers that divide into a number. Multiples are what you get when you take that number and multiply it by something. Okay, so I'm going to have you do a problem. I'm going to erase this. I want you to list all the factors you can think of 40, 40. Okay, it's your turn while I erase. You can write down 40 and whatever method you choose to use. Go and see how many factors you can find. Okay. Give you 30 more seconds. So what you want to make sure is it's really common with factors that you don't forget 1 and the number itself. So always there's a factor, there's another. Both of those can go into 40. 40 is an even number. 0 is an even digit, so 2 will work. Pretty easy to figure this stuff out. I picked the number that most people will get. See, 3 will, nope, 3 is not going to work. 4 works well. So a lot of people are mistaken thinking they've found 3 factors so far. We've actually found 6. If 1 times 40 equals 40, that's 2 separate factors right there. So 2, 4, 6 of them. And then always remember, if the number ends in a 0 or a 5, it can be divided by 5. So in this one, if you didn't think of it, 5 times 8. So hopefully you were successful there. These are all our factors. Okay. I want you to find at least 3 multiples. You're on. Doesn't matter what you come up with as long as they're multiples of 40. Okay, there you go. It's about all the time. Don't have too much lag time there. You might have listed 40, because technically 40 is a multiple of itself. 40 times 1 is 40. Okay. Now, if you take 40 and you multiply it by 2, you get 80. There's one. If you take 40 and you multiply it by 3, 3 times 4 is 12, but it's in the tens column, so that's actually 120. And then let's say you didn't have this top one and you started 40 by 4. I'm just going in order. You might not have if you did this by yourself. But there are some examples of multiples of 40. Okay, so you would use this type of thing when you're reducing fractions or factoring. In algebra, you would use this kind of thing when you're adding, subtracting fractions. Okay? So usually you're doing this kind of thing from probably, about 4th grade on. And then when you hit 7th and 8th in high school, you start using this with algebra. So that's what we're going to do now. So let me erase all this. All right, here we go. Okay, I want you to consider this. 20x, that's a variable now. We're not going to use it as a time sign when we're dealing with algebra. So this is what they call a binomial. It's 2 separate terms, 20x and 36. And what you're going to try to do is you're going to try to factor it. So what you need to do is think of the biggest number you can think of that goes into 20 and it also goes into 36. So you could try 2, but there's a bigger number than that. Okay, I hear you screaming out 4. I can just feel it. So 20 divided by 4 is 5. So 20x divided by 4 is 5x. 36 divided by 4 is 9. So 4 works. Is there anyone bigger than that? No. There's numbers that go into there that won't go into there and vice versa. So 4 times 5x plus 9, okay, equals that. But what you have to do is you have to put this in parentheses to make sure it works. So 4, remember the distributive property? Okay, remember that? You go, 4 times 5x is 20x. 4 times 9 is 36, so let me erase this again. Don't want to confuse the issue. So 4 times 5x plus 9 indeed equals what we started with. So 4 is a factor, and 5x plus 9 is a factor of 20x plus 36. So it's more complicated looking, but when you think about it, 4 divides into that, 5x plus 9 times. 5x plus 9 divides into that 4 times. So it's an extended idea of what we were doing with 24. And this form right here, if I may just put that in a square, is the factored form of that. You use that a lot in algebra where they'll say make sure and factor completely. So you're pulling out the biggest number that'll go into both things, and then you're rewriting it like this because this multiplies together to equal what you started with. Okay? All right, so what we want to do is Okay, we want you to try to factor one. So I'm going to give you one more thing to do here, and let's see if you can handle it. I'll give you a nice, easy one. Similar to this. By easy, I mean not too fancy, but doable. And you want to try to factor it completely. So let's go 12x minus 18. Let's see if you can factor that. So you start by thinking of whatever number can divide into both of them, and you hopefully can think of the biggest one that goes in. So what some people do is they go like this. They think of ways that they can multiply to get 12. And they think of ways they can multiply to get 18. And then you look at those two lists, and the biggest number that's on both lists, like there's 18, there's 12, but it ain't on both. The biggest number that's on both lists is 6. So 6 is the biggest factor that you can take out of that. So if that helps you. Some people can just do it in their head. There's other ways too. So if I divide, so I'm going to use 6 as one of my factors. Remember that parentheses. 12 divided by 6 is 2. Don't forget your x. So 6 times 2x is 12x. And 18 divided by 6 is 3. So 6 times 3 is 18. Don't forget your minus sign because this one has subtraction. And there you have it. This bugger right here and this bugger right here are factors. So you have successfully found the two factors that we need of this thing right there. Okay. Good job. All right, and that's it for today. I'm not going to do killer long math lessons. What I'm going to do is next week I'm going to start getting into that different kind of graphing with what they call quadratics with you. And that gets a little trippy. It'll be continuous lessons. A lot of this stuff you would have had in 4th quarter of 8th grade. I'm not sure if you'll get there, so it'll be a good preview or, whatever. But it'll give you a lot of basic skill work. You'll be doing this kind of stuff, creating different looking graphs. And there's a couple of real tripped out formulas you can get used to doing. So that'll start next week. This week we're concentrating on little fill in the gap things and get your brain fresh and up to speed. So today we discussed factors and multiples. Factors are the thing that can divide into the number. Multiples are when you take that number and multiply it by something else. We also talked in our music. Let me get over on this side, sorry. Talked in our music of our 1, 4, 5 stuff, where we find the key we're playing in, and we learn what the 1, 4, 5 chords that go together are. I'm always telling Mr. Tom at work and the other players there, trying to teach them this so we can just use that shorthand when we're discussing what chords we're going to use in a song. Well, it starts on the 4 chord, or it starts on the 5, things like that. And the more familiar you are with all this, the better of a musician and player you can be, because you'll be more comfortable. Okay? That's it. That's outro with some more. Finish up that Panther Blues. Said I was walking with my Panther. We went out in the woods. we never have to worry. The Panther's always good. Oh, we're walking with the Panther. We had to smile. Nobody come near us. Won't let 'em come within a mile. All right. Thank you all. See you tomorrow. Lesson number 3. Bye-bye.